Okay, we are starting our new unit over similarity, and we're going to start by going back to transformations, which we've already learned. And we're going to talk about the fourth type of transformation. We didn't talk about them, which is a dilation. So we talked about translation, reflection, and rotation. This is the last type of transformation, which is called a dilation. So a dilation is a transformation that produces an image that has the same shape but different size, either smaller or larger. So the pre-image, as review, is the original figure, or in this case, triangle ABC. The image is the new figure, which would be triangle A prime, B prime, C prime. Is a dilation an isometry, and why? Isometry means that it has the same shape and size. So we would say no, because it changes size. And then if you want a review of isometry, you might want to add this, same shape and size, or congruent. Okay, so these are not congruent. That might be helpful also. It says, in a dilation, a figure is enlarged or expanded or reduced, contracted, with respect to a fixed point called the center of dilation. Okay, so that's the middle of your transformation. A scale factor K is the ratio that compares the distance from the center of dilation to the image to the distance from the center of dilation to the pre-image. So your scale factor is whatever your center of dilation is, the distance to the image over the distance to the pre-image. Okay, so the new figure over the old figure. Okay, if K is between 0 and 1, the dilation is a reduction. So if it's smaller than 1, but larger than 0, then the shape is getting smaller overall. If it's larger than 1, then it's an enlargement or getting bigger. Okay, if it's equal to 1, then it's not a dilation because it stayed the exact same size. So what actually happens when a shape is dilated? So in this case, we have a scale factor of 3 to 1. So all of our side lengths got 3 times as large. Okay, that's going to affect our area in a different way, but for the side lengths, they're all 3 times as big. So it says A prime, B prime to AB was 12 to 4, which is the same as 3 to 1. A prime, C prime is 15 to 5, which is 3 to 1. And B prime, C prime is 16.5 to 5.5, which is also 3 to 1. Okay, all your sides are proportional. They're all a variation of 3 to 1. Okay, the angles. A is congruent to A prime. They're the same size. B and B prime are congruent, and C prime are congruent. So they are all congruent. Okay, your angle measures are not going to change, and your sides are going to be proportional. So the following properties are preserved between the pre-image and image when dilating. The angle measure, they're always going to stay the same. Parallelism, things that were parallel before are still going to be parallel. Collinearity, points on a line remain on that same line. Distance is the thing that's changing, but they're not just changing in a random way, they are still proportional, so there is a pattern. Okay, the shorthand notation for this is dilation. O is whatever your center of dilation is. So that could be the origin if it's O, and then K is your scale factor. So if it was around the origin, but a scale factor of 3, you'd replace that with a 3, and then whatever your point was. Okay, and if you're using it as a general rule, you'd still have X, Y in here. Find the scale factor and determine the type of dilation. In these, it's really important that you look at the difference between the pre-image and the image. Okay, in this case, my pre-image is outside of my image, which means this got smaller overall. It's a reduction. Okay, so my scale factor is actually 5/10 because you put the image on top of the pre-image, or 1/2. And since that is smaller than 1, this is a reduction. Here my image is outside of my pre-image, so I'm going to put 15/7. I mean, you could leave it like that because it doesn't simplify, and this is an enlargement. Determine whether the following situations are reductions or enlargements. Scale factor of 5/2, that's larger than 1, so it's an enlargement. Here, this is my pre-image because they do not have the apostrophes, they're not prime. So from B to B prime, it looks like we're getting smaller. So this is a reduction. Here, this is around the origin with a scale factor of 5. So this is an enlargement that's bigger than 1. Here, my pre-image is inside of my image. My image is on the outside, so it got bigger. This is an enlargement. Here, my scale factor is 0.5, or the same as 1/2. That would be a reduction. It's smaller than 1. And 2/3 is smaller than 1, so it's a reduction. Here, we're saying that our center of dilation is T. So I'm going to highlight that. And we want it to be 3 times as big. So if this was my original distance, I want to duplicate that so it's 3 times. So it'd be 1, 2, 3. That makes my new point P. 1, 2, 3. Okay, you could also label that because it's your image Y prime. It's the image of Y. Okay, on this one, our center of dilation is R. Our pre-image is F. So that's 1, 2, 3, 4, 5, 6. Half of that would only be 3. So 1, 2, 3, which is W, is our image. So this would be the same as F prime, but I'm going to put W down here just to be clear. All right. Same thing. So P is our center of dilation. We want P to R, or I'm sorry, R is the outcome. So we want something 4 times over to be equal to R. Or if we're reversing it, we want it to be 1/4 of that. So this is 1, 2, 3, 4. 1/4 of that would just be W. Okay, so you could say that this is W and this is W prime. Here, my center is H. I'm going to K. That's only 2 away. I want to take that 3 times over. So that'd be 1, 2, 3. So now I'd be at T. So that'd be my K prime. Here, our center is T. I'm going to M, so that's 2. And this means we're changing direction. This -2 means I'm going this distance of 2, and I want to double that the opposite way. So that'd be 1, 2 would land me at K. So this is my M prime. All right, this time we have F. My outcome is K. And that's supposed to be 1/8. So the opposite would be to take that 8 times over. So if I do that 1, 2, 3, 4, 5, 6, 7, 8, that puts me at D. So K would be the same as D prime. That would be 1/8 of that distance. Okay, the dilation is centered at O with a scale factor of 3. OA is 6. OB is 7, and AB is 8. And those are already on our picture for us. Okay, so we have to figure out the rest. If my scale factor is 3, that means that my full distance has to be 3 times as big. So 3 times 7 makes this whole piece 21, which would make just this missing piece 14. Here, 6 times 3 makes the whole thing 18, or just this piece 12, and 8 times 3 is 24. Now we should be able to fill in this list. All right, there we go. The dilation is centered at O with a scale factor of 1/2. OA is 6, OB is 8, and AB is 4. So those are already labeled again for us, and our scale factor is 1/2. So half of 4 is 2, half of 8 is 4, half of 6 is 3, and then if we subtract, those would be 4 and 3 also. We take the total, 6 minus 3 is 3, 8 minus 4 is 4. Now we should be able to fill in this section. There we go. Find the scale factor, tell whether the dilation is a reduction or an enlargement. Then find the values of the variables. Okay, so this is our pre-image, this is our image. It's getting bigger, so it's an enlargement. And we would take 12.5 over 5. Okay, so that's 2.5 or the same as 5/2. So that's what I'm going to use. This is an enlargement. And then I take each of these numbers times 2.5. So 8 times 2.5 is 20 for x. 4 times 2.5 is 10 for y. All right, last one. This is my pre-image. This is my image. It got smaller, so it is a reduction. And then let's see what we know. We have 7 over 12 for that side. So if I want to find what this one would be, I have to take 18 times 7/12, which is 10.5 for x. All right, so at this point you're ready to work on your homework assignment, which are pages 18 and 19 in the back of your book.